Factor. When I look at 20 through to 24 here, it says to factor these. Now we had problems similar to this. It didn't say factor though, it told us to find the zeros. And in the previous video, which was this one here, we found those zeros, which are down below here. But notice what the direction says. It says for the following exercises, use the rational zeros theorem to find the real solutions to each equation. So we're going to use that same idea here, not to find zeros, but to factor. So that rational zeros theorem tells us this, that we're going to use that P over Q again for this problem. And that my P is a factor of A naught. So I'm going to do 23 again. So this is my A naught right here. So P is a factor of 24. So that means it can be plus or minus 1, plus or minus 2, and then all the way down to plus or minus 24. And then we also have our Q, which is a factor of AN. And AN is this 2 here. So that can be plus or minus 1, plus or minus 2. So we're just going to set that all up and then take our P over Q. So that's where we're heading to with this problem. We're going to use the rational zeros theorem to help us factor here. And also the factor theorem. Those two together to be specific. So then our P is going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and then plus or minus 24. Then we're going to take our Q here, that's the 2, it's a factor of the 2. So then that's going to be plus or minus 1, plus or minus 2. Okay, so now that we have all the factors of both P and Q, now we're going to talk about P over Q. And then I'm going to end up, when I divide them all by positive or negative 1, I'm going to end up with plus or minus 1, plus or minus 2, and I'll just write them all out, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, or plus or minus 24. And then I have to get all the other ones when I put 2 on the bottom. So plus or minus 1/2, plus or minus 3/2. Oops, let me fix that 3. Terrible looking 3. That's a little better. 4, 6, and 8 divided by 2 is going to give me stuff I already have. 12 divided by 2 is also going to, and so is 24. So that's it. Okay, and now with those, remember, we're going to plug them in and see what we get. So we can start with 1 and go down. And what we'll realize is these are all not going to equal 0 until I get to f of 2. And f of 2 is going to be 0. So I know 2 is a 0 for this. So that tells me right away, if I know the 0, I know a factor. And a factor is going to be x minus 2. All right, so from this, I can divide using synthetic division. And then I can find the other factors. So I'm going to make a little room. So for my synthetic division, I have to put the 0 there, not the factor. And I put my 2, my 7, my negative 10, and my 24, which is also negative. Draw my line, bring down to 2 from here. Oops. And then 2 times 2 is 4, put it there. Add the 7 and the 4, that's 11. Times those, that's 22. Add the negative 10 and the 22 together, that's going to be negative 12. Multiply those together. Oops, it'll be a positive 12. 22 is larger than the 10. Multiply those together, that's going to be positive 24. Then I get 0. And that's an indicator if I messed up or not. If the 2 is not a 0 for it, I would get some other number than 0 for the remainder for the Rx. So this is going to give me 2x squared plus 11x plus 12. And I know that my other factor is x minus 2. So I factored it somewhat already, not completely, but more than it was. So now if I can factor this part here, the 2x squared plus 11x plus 12, then I'm done. Which I can, and I don't have to use the rational zeros theorem to do it. I could just understand what they are. And that's what it factors into. So that's a completed answer. And if you look at the video I found last time, or I did last time, I didn't find it, I actually worked it out last time, but for the zeros, notice what I came up with before I actually found all the zeros. I came up with it in factored form. So sometimes when we're dealing with these problems here, if it just says factor, I kind of do that along the way when I'm dealing with finding zeros. So this is the idea of what we're doing. And this is what I could be asked to do. I could say, hey, I got to factor this. So I could use the rational zeros theorem to actually factor. And that's what I want you to see in this video. And understand that, because if I give you some rational expressions, and let's say I get a cubic on top, how else are you going to factor it? This is our only way we can to do that. So keep that in mind when we move on to the next sections.